Welcome to the second assignment. It's about bash. Bash stands for born again shell. Born again shell. Bash is both a shell, the terminal, both a terminal and a programming language. We are about to dive into some bash scripting. We're going to work with commands and arguments and options. You all have already used a bash script when you install the course content with dbwebb. dbwebb is a CLI, it's a command line interface, and is written in bash. And we're about to create a couple of our own. I don't know how much you have programmed before, and because it's different student groups from different backgrounds. We start by scrolling down, we click on the guide, plop, and here we have a guide where you can lean on this guide. If you wonder, how do I do a if statement? Okay, then we check here under loops and conditions, an if statement. Okay, this is how you do it. So it's more of a reference page. Use it wisely. There are reference guides everywhere online. You have the manual, you have thousands of places online. Just keep in mind that you're all using bash 5, I think. I think it's bash 5 in Debian 11. You can see bash version. Yeah, 5.1. Whoa, 5.14. Great. Get out. So, some constructions, the structures work better with an older version or another shell, like SH or C shell or TC shell, or there are hundreds of different shells you can use. We use bash because it's widely used. That's the only reason. And so far it's the default shell when you install Debian. You have an exercise. Read it. Start from the top. And if we slowly scroll down, you can download it, or you can copy it from your example folder, because you have in the Unix example bash. There you have two files, one more relevant than the other, and the more relevant is this one, CLI with options. We go down to usage, and here we have different parts that the script can do. Compare it and see how it's done inside the script, because this is basically, it's almost the one part of the assignment. So look at the script, you look here, option, commands and arguments, and a description. What can I do with the script? And good programmers as we are going to try it. I don't even have... Oh, shame on me. In the day. Here we go. Now I have all the files. If we look in example bash CLI with options, and the script is called bash CLI.bash. we can see some parts here that, oh, this I have to change. This is the correct shebang. A shebang is a way to tell the script how it should be executed. And by using this shebang, it's very backwards compatible. Yeah. It's a more general way of triggering bash. A hashtag, except from here, is a comment. It's not getting executed. I don't remember what I was supposed to show. Yeah, how you should use the script. This is how it looks. I exit, I save it, and I step into the folder instead. Example, bash CLI. There we have it. I just run it without argument and options, and I can see, okay, run -- help. Okay, -- help. And then, as you can see later inside the script, you have a help section, a function that prints this help text. Here we can see the usage. We run the script, followed by some options, followed by a command, followed by arguments to the command. And if I just run the command 1, oh, my head is in the way, command 1, what happens? I get this is output from command 1. Okay, if we look at the script and we go down to the bottom. It's hard in Nano. Yeah, I use the arrow keys instead. At the bottom we have the structure that controls the commands and arguments. It's a while loop. I think all of you know what a while loop is. $#, it represents the number of arguments, the number of space separated strings we pass into the script. So while there are scripts, check the first argument. If it's in -- help or -age, then we call a function usage and then we exit the program. If it's version or just a single -v, then we run the function version and we exit the program. Command 1 or command 2 or calendar. Then we run command followed by, and then let's say we pass calendar. Then we trigger this one. And whichever we pass is going to end up in $1 because it's the first argument we pass. $2 is the second, etc. And it's space separated. I'm going to show you in a bit. So command ends up being calendar, command 2 or command 1. Then we run shift. It's a keyword that throws away the first argument, which is the script name. The command name, excuse me. So the rest of $@, because this one holds all the arguments. We throw the first one away because we have used it here. We don't need it anymore. And then we have a function called, in this file at least, up dash followed by the command. And you can see $command. It's a lot of command words. Dollar command is the value of the variable command that we create here. Okay, here we declare it. We give it a value. Let's say calendar. So dollar command is gonna have the value calendar. And here we call the function app-calendar in that case. And we pass all the other arguments that we have. And then we exit. And if we go up, we can see app followed by calendar. Oh, it's the first one. Function name, app calendar. Here's a local variable. It only exists inside the function. We declare it, we give it a value, and then we can output some content. Okay, and here you can see we have two commands that perhaps may not be installed on your system. Calendar is installed, it should be. I'm going to show you how to install cal. So you can try this script as is. If we go up, we have the other function app command 2 and app command 1. And we tried this one. Use these files and edit these files and try whatever you want in these files. Just perhaps back up the original. So if you mess something up, you can always go back to the original. Try it, play with it, and see what happens when you do different stuff. Lean on the bash guide. Okay, we exit this script. I know I'm sorry about it looks pretty bad when I use nano and show you. It looks better if you open it in your favorite text editor. I was about to do something. Yeah, calendar. This command, cal, shows the calendar. And it's not installed by default. But to install it, you run sudo apt is the package manager or apt-get. Both are equally fine. Install and ncal. Now I already have it, but for you it's going to get installed and then you can use the cal command. The calendar shows what happened these days. Some important dates, happenings. I don't know. Okay, two different commands. You can install the one with ncal. Yeah, gonna go through the arguments. We create an example file. I don't have to do it in the... I can do it here instead. I create a file called, what should we call it? Test.bash. That name is as good as any. I open it in some editor. Now it happened to be nano again. I add the shebang. And I'm ready to go. Now I have a bash script. I don't need to use the file ending .bash because in Linux the file endings are pretty pointless or useless. But it's good custom because then everyone who sees the file knows, okay, here's the bash script. So we add the file ending. Let's say I want to echo something. I save it. And by echo, it gets printed to std out. And if I just try to run it, you're gonna see, wow, that it won't work. Permission denied. I have to change the way the permissions on it, so I can execute the file. I can do it with +X. because that gives everybody permissions to execute it, and that's good. And then I can run the script, and the word something gets echoed out. Okay. I am not going to do the whole guide because it's a lot of stuff. So I comment that one away, and instead can echo the $@, all the arguments that getting passed. Run it without, nothing gets echoed. You can see all the arguments, whatever it is, gets printed out. And everything is space separated by default. So if you do a loop or something, the steps is the space. So you can loop the $@. We can look at that. Remove that one, and for value in $@. Do something. And then we are done with something. So this is the structure of for loop. You can see it in the guide as well. Echo, and then we have our value in $val. I think you recognize the structures, and I don't think it's so far from whatever you have programmed before. It's just a different syntax. So we echo the val. You run it again, and here we can see that val each iteration is separated by the space, the internal field separator. The best way to attack this assignment is to go to the exercise, you look at the script, you execute the script, you see what happens if I try this command or this command, and you can follow the path inside the script. What happens? How does the function get called? How do I pass the arguments? The best way to learn is learning by doing. So try it, keep a safe copy somewhere, and nothing could happen. Nothing can go wrong. And if you end up messing up your whole virtual machine, you can just create another one. No worries. So you have a template. Continue read, because this whole document, article, explains that template, the CLI with options. All the parts in it. It's pretty long, I'm not gonna bore you with it. And the assignment are 2 labs, and I think there is a video on how you create the labs. Yeah, I think it is. And 2 scripts should be created. Just click on it and you can see the instructions, the requirements. If something is confusing, or if you wonder, does it mean this and this, contact me on Discord. If it's something that doesn't come through the requirements, it's up to you to choose however you want, because when you're gonna loop through numbers, do it however you want. For an example. And in this case here, create a script that's called if2.bash. This is important, the naming of the files. Then name it as the instruction says, or else I have to search all your files or the one who is correcting the assignments. And it's it's meaningless time. But like this one is supposed to print higher, lower, or same. You're not getting an error if you print something else. If you print this value is higher, for example. That's not the important part of the requirement. The specific text that gets printed. Don't forget to publish. If you don't publish, we can't see your files. And then you have the one who's pretty much following up on the exercise. You're going to create a script with arguments and options. The labs I can show you pretty quick, even if there perhaps is a video or a video. I think it is a video. So here we go. First of all, we step into the root of the course folder, Unix. dbwebb create bash1 is the name of the first lab. As we can see here, dbwebb create lab. And the first one, dbwebb create bash1. And here you also have the instructions on how to write the code. Enter your bash code within $parentheses. And the reason is we can look inside the file instead. I create bash1. The files get downloaded and they are put here. Just as the instruction says, you can find the lab and all files here. Great. 0 to bash1. Here we go. We have different files. Ah, no. That alias is not done. Okay, we have 3 files. Answer.bash, that's the file you are going to work in. Apache 2, it's a folder where you are supposed to execute the lab instructions. That's the Apache folder you're going to work with. For all of you who have done assignment 1, that Apache is long gone. You can forget about it and look forward and use this folder Apache. Instruction.html, it's the same as we have in answer.bash, but you can view it in a browser. It gets more readable than it is in answer.bash. Because this is how it looks. Can I do this bigger as well? Almost. This first part, you can ignore it. It's just some basic information, which course it is, which lab it is. This is the unique ID for this created lab. Version, acronym, and time and date, version, etc. Just go down until we have the first exercise. Instructions. When you open this in a web browser, you don't see all the comments. Try it and it will look better. Section 1 is about ls, the ls command, where you list stuff in a file. Use the manual if you get stuck. It's hard to use the manual, but try it, and then it's learning by doing. The more familiar you're gonna get with the manual, the easier you have to learn new commands and what the commands can do. Because almost all the commands have an entry in the manual. You can also view the manual online. Just Google man ls and you're gonna find it. I can't scroll. Come on. I used the keys instead. Here we go. Exercise 1.1. 1.1. Does it say 1.1? 1.1? Okay, the first exercise. Use the command ls to list the files and directories in the Apache 2 directory. List one file or directory per line. It's pretty straightforward. It's a tip. Use the command man ls to see the flags that can be used for the ls command. Write your code below and put the answer into the variable answer. And as we saw in the instructions, to be able to see the answers, we remove this string, and then we're going to use something called command substitution. It's $ and parentheses. Whatever we type in here, the value it returns, the result of the command, gets returned and into the variable answer. So for example, we're going to list the files in the Apache 2 directory. ls Apache 2, because the lab is in the same folder as the Apache 2 folder, as we saw before. This should do well. When we want to try out our answer, just run the lab as a bash script, and you get immediate feedback if you're right or if you're wrong. And this first exercise, I think they have changed something in how the ls behaves. Before, I think even last year, you had to look in the manual for ls, and then if you type Shift 7 on a Windows keyboard, a slash, then you can search for something. And perhaps search for line, because the question said list one directory or file per line. Enter, and then we start the search. And the letter N, step forward to the next one. And then we go down and we can see if we find something that's perhaps similar to what we want. And here we have -1, list one file per line. Then you had to add this option. Q for quit. We step into the lab again and go down. So before you had to do it this way, ls-1. Now it's enough with ls Apache 2. If you get an error and you want to see a hint, you can change below each answer. You have this boolean value, true or false. Change false to true. Okay? Good luck. Let me know if everything's go well or if you get stuck somewhere. Or help each other. Bye.